I code a DeFi project in 3 minutes. So I created a DeFi project that has a stable coin and then a non-stable coin, I guess you could call it. And you can stake the non-stable coin in return for staking rewards. You can also put the non-stable coin up as collateral so you can get a loan of the stable coin. And both the stable and non-stable coin contracts are upgradable. The most complex part of this is making both contracts upgradable. If you didn't want to make them upgradable, you could probably knock this project out in like 45 minutes or an hour. It's pretty simple, but making them upgradable makes it a little bit more difficult, and I'm going to show you how you can do that. So these are the contracts. The top 3 are for the stable coin, and the next 2 are for the non-stable coin. And the proxy contract is what the user interacts with directly, and the implementation contracts are where you store the logic for the proxy contract. And that applies to both the stable coin and non-stable coin. So I'm only going to go over one of the functions because I only have so much time, but we're going to go over this function right here, and this is going to give you a good understanding of how upgradable contracts work. In this function, we're going to deposit non-stable coins as collateral in return for a loan that's in the form of stable coins. So how this works is we're going to send a function call to the stablecoin proxy contract, but the function signature is not going to be in this contract, which will trigger the fallback function. And the fallback function is where we delegate the call to the implementation contract, which is where the logic is stored. So we're going to send in the function signature for this function, and this is the function that will be called when the proxy contract delegates the function call to the implementation contract. But we're also going to send in encoded function calls for the approval and transfer of the non-stable coin, which will be done from a different contract. So then we call the proxy contract of the non-stable coin, and we send it the encoded function call to approve the transfer of tokens. But the function signature will not be in this proxy contract, so it'll trigger the fallback function, and then it'll delegate that call to the implementation contract for the non-stable coin. So this is where the logic for the approve and transfer functions are kept for the non-stable coin. So to reiterate, we're calling the proxy contract of the stable coin, which is delegating the call to the implementation contract of the stable coin, which is then going to call the proxy contract of the non-stable coin, which is then going to delegate the call to the implementation contract of the non-stable coin. Okay, so I encoded the function call for the approve function. The first part is the function signature. The next part is the first parameter, which is my wallet address. The next part is the address for the stablecoin proxy contract. And then the last part is the amount, which is 10 coins. Okay, so I also encoded the function call for the transfer, and I'm about to encode the lending function call, and I'm passing in the function calls for the approval and the transfer. So now we're going to send all of that to the fallback function of the stablecoin proxy contract. Here's a transaction on Etherscan, and as you can see, we sent 10 non-stable coins to the smart contract and received 5 stable coins in return as a loan, and we also burned 1% of the transfer of the non-stable coins.